Alright, so our last segment for the doubly linked list, or the last video or two, are going to concern the remove method, which again is going to be pretty much symmetric to the way we did the add method. Public remove an item at int index. It's not going to be a huge issue to do that, right? And what we're going to do is e to return, or I'll give it the removed item, and return removed. Okay, it says it may not have been initialized, so I'm going to go ahead and initialize it to null. Okay. So again, we have the 5 scenarios we want to do. First, if the item is out of bounds, or the index that we want to remove is index is less than 0, or the index is greater than or equal to, in this case, the size, right? Because you can't remove something at size index. Return throw, sorry, not a return, but a throw new index out of bounds exception. Foobar. That's going to be a very cryptic error message, I'm sure. Alright, else. So again, we have the other 4 cases, right? So the first case is if size equals 1, right? Not size equals 0, can't remove anything from a list of size 0. If the size of the list is equal to 1, we are going to go ahead and just remove the last item. Else, if the index is equal to 0, we remove the very first item in the list. We're removing the head. Else, if the index is equal to size minus 1, that's the index of the last item in the list, the tail, so we're going to have to remove that. Else, remove anything else. Alright, so removing the last item in the list is fairly straightforward, right? And last being the last thing, the only thing in the list. Removing the only thing in the list, fairly straightforward. It's both the head and the tail, if you remember from earlier. So all I have to do is simply say head is equal to null. So this is a bit weird since I'm explicitly setting stuff to null, and tail is equal to null. So I'm just simply say don't point to any node anymore. The list is done with, right? And we'll want to remember to do a size minus over here. So the size keeps, consistent. Alright, so if size is equal to 0, head is null, tail is null. Else, if the index is equal to 0, what do we want to do? We want to remove the first item in the list. Otherwise, we'll remove the last item in the list. And again, these two things will work symmetrically. So I'll go ahead and draw them and as I'm working through them. Okay. So let's go ahead and boom. Delete. Alright. So suppose we have a doubly linked list here. 1 node, 2 nodes. Right. We want to remove the head of the list. And let's go ahead and just say these are the only guys here. Head. Okay, boom. And then we're going to make a tail. Okay. And now we'll just draw our pointers accordingly. Technically the reference is, but alright. So we've got our head and our tail. We want to remove the head of our list. How are we going to do that? Well, in the old way of doing it, in the singly linked list, just making this guy was all I had to do to make him the head of the list, right? saying that head of the list is equal to the head.next. Right, and moving this over. That was all I needed for a singly linked list. But unlike in a singly linked list, there was nothing pointing to this guy anymore, because this wouldn't exist here. But since I have these .previous pointers, I still have a reference to this guy that we need to get rid of. So now the new head .previous is equal to null. And that will get rid of it. Of course, I should remember I have to return the removed item, so I'm going to do that. So I need to do that for those other two cases. Removed is equal to head.item. Removed is equal to head.item. Head is equal to head.next. Head.previous is equal to null, so this points to nothing, which means that the garbage collector takes care of him, which means no more arrow pointing to this current head of the list. Okay, that's all we do. So now, what if I want to remove the tail? Well, first I need to save the tails item. Removed is equal to tail.item. And again, if you've been having trouble following along with these, it's easiest if you can, once you can draw these out. It's more important that you are able to draw these out, then you'll be able to code them up. Removed is equal to tail.item. Okay. Now, similarly, rather than, what we want to do is we need to make this guy the new tail of the list. Okay. So the way we do that is saying tail is equal to the current's tail, the thing behind it, which is tail.previous. Okay, and then we have to remove this. We have to remove this arrow, so that there's nothing pointing to him now. Tail.next is equal to null. Now there's nothing pointing, so we can delete that. And good riddance to it. And those are those cases for removing the last item in the list and the first item in the list. And let's go ahead and do that now. So sout l.remove index 0, sout remove. So now there's 3 things in the list, so we can remove index 2 to remove the last thing. So this should leave us with EA, and we've removed F and B. So those are working just fine. Okay, let's go ahead and set up for the last remove case. Right, the next remove case is removing everything from, removing a random location. So that'll be in the next video.